Hello! Welcome back! On this very special episode of Antiformal, we are actually going to be introducing a new mini-series called IntoIntro. My name is Bryn Cable, your club archivist, and this is...
My name is Emma. I am the secretary of Pick and Hammer. So if you're a current student of geology, a prospective student with questions, or you're just interested in some cool geologic facts, welcome!
Today we are going to be using the scientific method to help identify minerals. It's not just scientists that use the scientific method. All people learn in a manner similar to these steps, and it all starts by noticing something.
The first step of the scientific method is observation, and this is when you take the time to gather information or data about a phenomenon or problem that you're trying to solve.
Then you have to think about what you expect to happen. What are you changing? This is likely when you will establish your dependent and independent variables. In science, we try to keep as many things the same as possible so that we can isolate the effects of the independent variables. This is what we call developing a hypothesis. You are making an educated guess on how the independent variable will affect the dependent variables.
Next, you have to make a prediction based on your hypothesis. If your educated guess is correct, what will happen? Remember that predictions are testable, so thinking about what you expect based on observations is going to help you set up your experiments.
Now we must perform the experiment. This is where you get to see if your idea matches up with the identified problem. This can be as complicated as collecting grain sizes on LPSA over the course of months, or just pouring sugar into your tea to see if it'll dissolve.
During an experiment, you collect quantitative data. After you run your tests, you have to think critically about the results. Was your prediction correct? If your hypothesis was proven wrong, you just have to make some more observations and start over.
If it was proven correct, you should test it again. If the same results occur and those same results can be reproduced by others following the same method you did, then a hypothesis could be on its way to becoming a theory. A theory is most likely the correct answer, but may still be disproven as new technology emerges. Laws cannot be disproven, like the law of gravity.
One way to apply the scientific method in geology is through the identification of minerals. Every mineral has specific properties like hardness, cleavage, luster, and streak that help us identify them.
Let's look at cleavage first. Mica has one plane of cleavage, which means that these flat surfaces will only occur in one direction. So both of my fingers are pointing in the same direction, so that's one plane. Whereas Galena, on the other hand, ooh, there's a hair, has three planes of cleavage, because we can see that there's a flat surface on the top, there's a flat surface on the side, and then there's also a flat surface going this way. So that is three distinct planes. And it gives these images of cubes when you have three different planes. Some minerals don't have flat surfaces at all, like obsidian, and they break in these curved fractures that we refer to as conchoidal fractures. That's because their structure in the inside, they cooled so fast, obsidian cooled so fast that it didn't have time for the atoms to align in a structure, so there's no weak points to create those perfect planes. It's just curves.
Now let's talk about hardness. Every mineral has a rating of 1 to 10 on the Mohs hardness scale, with 1 being the softest and 10 being the hardest. Minerals like gypsum are so low on the hardness scale that you can scratch them with your fingernail, like so. Other minerals, like fluorite and apatite, have a hardness around 4 to 5, which means they can be scratched by a plate of glass. Quartz and corundum are higher on the hardness scale. Quartz has a hardness of about 7 and corundum has a hardness of 9. It's the only mineral right below diamond, which is the hardest on the scale. So these are so strong that they can't be scratched by glass. They can't be scratched by a steel nail, your fingernail, or any of the other indicators. They can be scratched by each other. Corundum can scratch quartz. Yikes. Corundum can scratch quartz. So this is a good indicator.
And now I'm going to talk about mineral habit, which is how they grow. Mineral habit refers to how the atoms align as the mineral is growing. We interpret this as a shape. Calcite will always have a distinct rhomb shape with angles at around 120 degrees and 60 degrees. Another mineral that grows in a specific shape is hematite, which will have 4 planes, creating a diamond shape similar to those above the Sims head if you've ever played Sims. Another habit specific to calcite is effervescence. If a drop of HCl reacts with a rock, calcite is present.
Some minerals exhibit a specific luster, which is how the light reacts with the surface of the mineral. So there are several different types of luster, including metallic, greasy, glassy, and they're good indicators. Here we have graphite, which has a greasy luster. You can kind of tell the light shines on it, but it's dull. So that's a good way to tell. This doesn't have to do with the light, but if you feel graphite, it also feels kind of greasy. Minerals like pyrite and galena are metallic, and they shine a lot in the light, like a piece of metal would. So this is how you can identify metallic luster, like so. And minerals like obsidian have glassy texture. So if you hold them up to the light, it looks like you're looking at a piece of glass.
It is always a good idea to look at the color of a specimen. Color can tell us about impurities included in the rock, staining from fluid movement, and may even hint at trace elements in some instances. However, color should not be used as a primary tool for identification. Many rocks come in multiple colors. Sometimes different colors of the same mineral get different names, like amethyst and citrine are both quartz, or aquamarine and heliodor are both beryl. Malachite is a rare example of an evaporite that is always green. Azurite is another evaporite that commonly grows with malachite, and it is always blue. This is a rare instance where we can use color to identify.
In the lab, you can use a streak plate to test the residue that a mineral leaves behind. Sometimes a mineral doesn't leave any streak on a streak plate at all, and that can be an indicator in itself. But sometimes specific minerals have a specific color streak that they leave. For example, hematite will typically leave a black streak on a streak plate.
Thank you for watching, and we'll catch you next time.
Bye!
Welcome back to another episode of Antiformal, a video cast by Pick and Hammer. Today on the show, I have the lovely Emma.
Hello, everybody. I'm Emma, the secretary for Pick and Hammer. I'm happy to be here.
She's going to be helping me with Mineral of the Day and then going into a little mini interview to get excited for some upcoming club adventures. But first we have our Mineral of the Day, Galena. So I'll show off some Galena samples if you'll read some facts.
Absolutely. So here we have Galena. It's a lead sulfide with a metallic luster along its cleavage planes. You might be able to see it's got some cubic crystal habits, which are really characteristic. It has a specific gravity of 7.5 and a density of 7.6, so it's very dense. Galena is the primary ore of lead and is often mined for its silver content, and it can be used as a source of lead in ceramic glaze. And if you're into some more metaphysical properties, Galena is said to be associated with self-transformation and the root chakra. You can find Galena throughout the continental United States, especially in the Mississippi Valley. Galena is the most important ore of lead. Silver is often produced as a byproduct, and most lead is consumed. Oh, fuck. That sounds weird when you read it exactly like that.
That's okay. Summarize it in your own words.
Galena is the most important ore of lead and is often mined for silver as a byproduct. It's consumed in making batteries, and significant amounts are also used to make lead sheets, pipe, and shot.
In this specimen specifically, I was showing it off a little bit earlier, but you can see this gold color, so that's pyrite, and it's growing with Galena right here because they both share sulfur in their chemical formula. So lead sulfide makes galena, and iron sulfide makes pyrite. So you can see them kind of growing together, and this is one of our outreach minerals that we take to a lot of different schools, because since there's a big clump of galena right here, you can feel that this side is obviously more dense than this side. So when the kids rotate it in their hand, they can feel that weight change. And it's a really cool activity to watch them do. So, all right. So, Emma, when you came to OU, you were not a geology major.
I was not a geology major. I didn't really think about geology at all.
That's okay. Would you care to share the story of how you decided to become a geology major?
Well, I am from New Jersey, which is pretty far. So I came to OU because I read online and I looked and I came and toured and I saw that the Weather Center was a really just great facility, and I wanted to be a storm chaser. So
Okay.
yes, I was very excited, and I had never experienced storms like there are in Oklahoma, and that was my path. I was decided. So I came to OU as a meteorology major, and I didn't really think much beyond that. I was just ready to go. And then my freshman year, I was picking classes, and I wanted to take severe and unusual weather because I like severe and unusual weather, but it wasn't available. So I decided to still knock out the science elective, and I took intro geology. And in that class, I had so much fun. Like it was so interesting, and I didn't expect to like it as much as I did. I didn't really think much of it at all. It was just a class you have to take. And I ended up hearing about the freshman geology field trip because I was in the class and eligible to go. And I went and I met a lot of really amazing people like Bren.
Thank you.
Yeah. And then I decided that I wanted to minor in geology. So I added that and I kept up with classes. I enrolled in mineralogy my sophomore year.
That class.
It's a big one. Really, really cool information, but it's a lot. But anyway, I was taking meteorology classes, and I found that I was just spending a lot more time focusing on geology, and it was just a lot more interesting, and I was having a lot more fun, and I decided that maybe I liked geology more, and I ended up switching my major, and I have not regretted it. It's a really, really great field to be in.
Yeah. I'm glad you switched over. I like the genre of people that geology reaches, because I feel like we're all pretty laid back.
I agree. Very, very relaxed. Very much know what you like.
Yeah.
And just trying to have a good time.
I'm glad you changed your major and came over to the rock side.
Yes.
So you've done some research since you got into geology. You've done some of your own undergraduate research.
This is true.
Yes.
I work for Dr. Michael Sorgan in a sedimentary lab. I have been looking at, since sophomore year, sediment samples, most recently sediment cores from Lake Tanganyika in East Africa, which is a really big rift lake with a lot of cool stuff going on. Specifically, I look at the sediment grain size and distribution through the core to try and figure out if there's any climate or anthropogenic related reasons for differences in what we're seeing, and differences that we can relate to differences in sedimentation over the last couple hundred years.
Mm-hmm.
So I get to work in the sedimentology lab, get to use really cool machines like a laser particle size analyzer and what's it called? The freeze dryer.
Yeah.
Like the freeze dryer. And it's been a really, really cool experience. I recommend reaching out to professors if you're interested in doing undergraduate research. It's a really enriching experience, and you know, you don't always have to follow through all the way with what you're doing, but it's really great to kind of have options and like kind of figure out what you like and learn some really valuable technical skills.
For sure. I've heard from an adult at OU, so like an official person, that some companies will even consider undergraduate research to be just as important or respectable as an internship.
Wow.
So yeah, I mean, it's very significant because you're in charge of your own little project, especially if you present it. Are you presenting in April?
That's the plan.
Okay,
yeah.
I am too.
That's cool.
Cool.
Yeah, cool. Symposium, okay. April. Be there.
Be there. Okay, so the last scheduled question I have for you is any expectations for the upcoming Tucson trip?
So, I have never been to Tucson before, with the club or otherwise. My first time at the Tucson Gem and Mineral Show, which I've heard wonderful things about. So I'm very excited. My expectation is to have a great time, and I'm also excited to be in this kind of like trip like setting with the prospective officers, with members of our club, because I have past experience like with trips and stuff, and you kind of it's a completely different environment, and it's very like conducive to like forming friendships and like getting closer, and I really like that. And also I'm really excited to kind of like see the vibe of the Gem and Mineral Show, because I know there's a lot of vendors from all over the world,
everywhere,
and I think it will be really interesting to interact with other people that like make rocks and minerals their life in like all different capacities. So I'm excited. It's gonna be a good time.
Awesome sauce. Do you have any questions?
I could ask like what it's like to buy, like to go up to a vendor and like purchase a mineral. Like, do you guys like barter a lot, or is it just
when London went with us, he kind of went to tell us how to barter, because it's clear that everybody there has put prices higher than the thing is quote unquote worth. Value is a really complicated subject, but you can haggle most people, but it's impolite. So it's kind of like a, how do you do it politely? And because we're a university club, we're saying like we're a student run club, like is there anything you'd like to contribute? We do a lot of outreach and spread geoscience awareness. But yeah, sometimes if it's somebody who clearly has like a really large inventory, yeah, you can barter with those people if they're selling like specimens by themselves. Some people you can't. Wholesale vendors you can't, because that's wholesale.
Right.
So we just buy the flats. All of our flats in those white boxes, those come from wholesale vendors. So yeah. We do a little bit of bartering, and some of them will try to talk with you at a level that's far beyond anything I've experienced, and then you're just like, oh, calcite!
Right.
Yeah.
Oh, wow.
But it's fun, and that's part of the reason that we have to incorporate people who are new to the club and may not end up being an officer, because it's so important to make sure people understand how this club makes its money and how it's able to do all of these fun trips. And we don't have member fees, and we give free food every meeting.
Right.
And pre-COVID, we did movie nights and a ton of social activities. So it's just very important to make sure that the club knows how to keep going, because our outreach money is of course separate.
Right. So it really is a central part of Pick and Hammer.
Yeah.
Getting these minerals and like using them for outreach and selling them. So
Yeah. I think it'll be really fun.
I'm excited.
Well, thank you for your time, Emma.
Thank you for having me, Bren. It's always great to be here.
Always great. See you later.
Have a great one.